Good day, grade 11 learners! Welcome back again to our session in calculus. Today, we are going to talk about solving problems on circles. This is a continuation of session 3 on circles. This is Teacher Beth again, your facilitator in calculus. Our specific objective for today is solve problems on circles and its properties. Alright, let's try to answer this first problem. Given the equation 4x squared is 4y squared minus 16x plus 40y plus 67 equal to 0, determine the standard form of the equation of the circle. Identify its center and radius and sketch its graph. Okay. To solve that, we need to write first. We need to write the given. Then the next thing that we're going to do is we transpose the constant here, 67, to the other side of the equation. So let me copy this one. What will remain to the left side of the equation is 4x squared plus 4y squared minus 16x plus let me fix this, plus 40y, and this will be equal to negative 67. Okay? The next thing that we're going to do, because is left on the left side of the equation, are terms which are divisible by 4. So we divide both sides of the equation by 4. So we get here x squared on the left, x squared plus y squared minus 4x plus 10. Let me change that. That is 10y. Okay, equal to negative 67 over 4. Alright. Now, if you can still remember the standard form of the equation of a circle, standard form of the equation of the circle, let me change the font into red so it will be clearer. Standard form of the equation of the circle is quantity of x minus h squared plus y minus k squared equal to r squared. So we need to achieve this form so that we will be able to determine the standard form of the equation of the circle. Right? So to do that, let's group together the terms in our equation, given equation, the terms with the same variables. So we write together them in groups. So we have x squared minus 4x. This is one group because they have the same variable, the x. Okay. Plus, we have y squared plus 10y. Okay, equal to negative 67 over 4. Okay, so now have groups of binomials, and so that we can come up with this left side of the standard form of the equation of the circle, we try to express these binomials into perfect square trinomials. Would we be able to do that? Yes, of course. What we're going to do is to find the third term of this perfect square trinomials, and to identify the third term, what we're going to do is we divide the second term of the binomial by 2, constantly by 2, and then square the resulting quotient. Okay, so the first term we have 4. We don't need to copy the negative 4 there because we're going to square it after. So 4 divided 2 is 2 squared is equal to 4. And so we have here x squared. We need to add 4 based on what we just have. And so we have negative 4x plus the result of 4 divided by 2 and then square is 4. So we add 4 here. This is now one perfect square trinomial. Okay? Plus, second term is y squared plus 10y. So we have 10 divided by 2 is 5. We square it. We have 25. Okay? So we add 25 to this side. Y squared plus 10y plus 25. Okay, and this is equal to negative 67 over 4. Okay, so next is we express this here into square of a binomial. But before that, remember we have added positive 4 on the side. In the first binomial, we added positive 4. The first perfect square trinomial rather. And the second, we added 25. To maintain the equality, we also need to add these values to the right. Okay, don't ever forget that. That's where most of the errors come from. Students forget to add, balance the equation. So because again we have added a 4 and a 25 to the left side of the equation, we need to add the same value to the right. Okay, now we can proceed to transforming these perfect square trinomials into the square of a binomial. To find the binomial, just need to get the square root of the first and the last term. So the square root of x squared is x, and the square root of 4 is 2. We square them. But what do you think is the sign in between? It's going to be the sign of the middle term of the perfect square trinomial. So that's minus. Plus, we do the same thing on the other perfect square trinomial. So we have y. Sign of the second term is positive. So we have plus here, and the square root of 25 is 5. Okay? And this is squared. And we simplify the other side of the equation. This now is equal to 4. So we have negative 67. Negative 67 plus 16 plus 100. Okay, and we simplify that further, and so we have here x minus 2 quantity squared plus y plus 5 quantity squared equal to, this is over 4, this is over 4, and that's 49. Negative 67 plus 16, may verify, so that's negative 67 plus 16 plus 100. So that's equal to 51. Okay? Wait, I need to verify this. 16 plus 100 minus 67. Okay, 49, correct. And because we need to express that into the standard form of the equation of the line, the circle, we need to find r squared. We need to find r squared. And r squared is equal to the square root of this. So that's 7 over 2 quantity squared. Right? Yes. And finally, we have the equation of the circle in standard form. And that's equal to x minus 2 quantity squared plus y minus 5, plus 5, y plus 5 quantity squared. And this is the standard form of the equation of the circle. From there, we can say that the center of our circle is at, look at these values, this is the x coordinate of the center, this is the y coordinate of the center, but remember it should be y minus k. So since this is y plus 5, then this should have been y minus negative 5. Right? Therefore, the y coordinate would be negative 5. Right? So our center is at positive 2, negative 5. And the radius of our circle, this value here, this one. Yes, let me mark this. Okay. Alright, this value is 7 over 2 or 3.5. So the radius is equal to 7 over 2 or 3.5. Now our next concern is to sketch the graph. So to sketch the graph, we just need to draw. Center is at negative 5, so negative 2 and then 5 for y. So we just need to draw a Cartesian coordinate system. Suppose this is our x line, the y line here, the y-axis, y, and this is our x-axis. X-axis. Alright, let's try to identify mark the grids. So we have 2 and negative 5. Let this be 1, 2. Let this be 2. And negative 5. Let's try to make the grids equal. This is negative 1, negative 2, negative 3, negative 4, and negative 5 somewhere here. Okay, negative 5. So therefore, the center of our radius is somewhere here. Okay. Somewhere here. And we need to have a radius of 3.5. So 3.5, that's 1, 2, 3. 5, that's another end of our circle. Now there is 3, so this should have been at somewhere here. So this is 5.5, this point. Then we have 1, 2, 3.5. It should have been somewhere here. And that's down below. And then we connect its points. Should have been an extension down there. The bottom point actually is at 5 plus 3.5 at negative 8.5. Okay, so negative 8.5 is part here. This one is 1, 2, 3, negative 1.5. This is 5.5, and this is negative 1, 2, 3, negative 1.5. So this is our circle with the equation x minus 2 quantity squared plus y plus 5 quantity squared equal to 7 halves squared. Alright, let's proceed now to problem number 2. Given the center of the circle at 3, negative 2, tangent to the x-axis, determine the general form of the equation of the circle, identify its center and radius. Okay, so let's try to solve this problem. Because it is given that the circle has its center at 3, negative 2, its tangent to the x-axis, the best thing to do here is to try to illustrate the circle. So let's try to draw the graph of the circle. Let me have this x-axis here for our Cartesian coordinate system. I mean the y-axis, and the x-axis this side. So x. Okay. Center is at 3, 2. Let this be 3. And this is 2. Negative. Okay. The center of our circle is here. This part. That's where the center of our circle is. So we have the given the center at 3, negative 2, and we don't have yet the length of our radius. So radius is equal to, don't have the value of the radius yet, I mean the length of the radius. Find that, know that this point here is already the center of our circle, and the center of our circle connect any points on the circle will give us the length of the radius. And since we are given that the circle is tangent to the x-axis, and this is our x-axis here, when we say tangent, it means it touches the x-axis. Therefore, from this center to that side there, this point is point of tangency. This is the point where the circle touches the x-axis. So therefore, the radius then of our circle has a length equal to 2. Okay? So that's 2, and this should have been the other end of our circle. Another end of our circle, this should be 4 here. And this should have been 5. Alright, so if we draw the circle would look like this. Now let me touch this point. Okay. Alright, so that's our circle. I'm already trying my best to really make it as perfect as it should be. Alright, so this is our circle with center at 3, negative 2. Therefore, then, our radius again is equal to 2. The radius is 2. So, let me indicate it here. Our radius is 2. So, to write the equation, general form, we need to write first into standard form, and then we just need to simplify it further so we can come up with the general form of the equation of the circle. And so, let's start by substituting these values to the standard form of the equation of the circle. So again, standard form of the equation of the circle is x minus h quantity squared plus y minus k quantity squared equal to r squared. And substituting the value of h and k and r to our equation, we have x minus 3 quantity squared plus y. This time our a is negative 2, so this becomes y plus 2 because that's going to be y minus negative 2, and when we simplify that, it becomes y plus 2 equal to the radius, which is 2 squared, okay, equal to 4. Therefore, equation in standard form is x minus 3 quantity squared plus y plus 2 quantity squared equal to 4. But we are not asked of the standard form of the equation of the circle. We are asked to give the equation of the circle in general form. So to find that, we just need to simplify the standard form of the equation of the circle. Simplify it together, so we have squared, the first square of a binomial, minus 6x plus 9 plus the second binomial, we have y squared plus 4y plus 4. And since I have already said that when we write it in general forms, all the terms except 0 should be on the right. So this constant here, which is 4, will become negative 4 when transformed to the left side of the equation, and what will remain on the right is 0. And we simplify the equation further. We write together beside each other x squared and y squared. So this negative 4 and 4 becomes 0. So we have minus 6x plus 4y. And we have one remaining constant, 9 plus 9 equal to 0. One way of verifying whether you have already counted all the terms in the equation is to try to count. Okay? So we have 1, 2, 3, 4, 5 terms, the second to the last line of the equation in the left side. So the final answer would also have 5. 1, 2, 3, 4, 5 terms also to the left side of the equation. So therefore, this is it. So our answer, the general form of the equation of the circle, given that the center of the circle is at 3, negative 2, and that the circle is tangent to the x-axis, is x squared plus y squared minus 6x plus 4y plus 9 equal to 0. And that's it, math learners. I hope you have learned something today as we tried to answer 2 problems pertaining to the properties of circles. See you next session. Bye!